All right, isosceles triangles are triangles that have two congruent sides and two congruent angles. You could also say equal there. So if two sides, so we denote the sides being equal by putting those little tick marks there, then their opposite angles, so the angles opposite of each of those, so think about drawing a line that way and a line that way, okay? Those angles also must be congruent or equal. The reverse must also be true. So if I tell you that there are two angles that are equal in a triangle, it must be an isosceles triangle because those sides across from those angles would have to be equal. Okay? There are lots of examples. I am not going to go through every one of them. I'm going to go through 3 of them, and then the rest of them you can find on OneNote to check your answer as a should-do assignment. All right, so example 1, in the triangle PQR, we know, actually, let me switch that around for this one. According to our statement, angle P is congruent to angle Q. And PQ is 6x minus 12. PR is x plus 20. And RQ is 8x over 3. We need to find the length of all 3 sides, but before we can do that, we need to figure out what x is. So according to our theorem here, if we have congruent angles, we have congruent sides, which means that I would set x plus 20 equal to, because they're the same, 8x over 3. And I'm not sure if we've done a division problem like this before. So you might be like, I don't know what to do to solve for x. But it's actually a pretty easy step. If something is being divided by 3, we can undo that by multiplying by 3. But if we do it in one spot, we got to do it all the way across the board. So 3 times x becomes 3x. 3 times 20 is 20, 40, 60. And then when we do 3 times 8x over 3, the 3's cancel, and I'm just left with 8x. Then I want to combine the x's together. So I'm going to subtract 3x from both sides. That's going to leave me with 60 equals 5x. My pen must be extremely dead. I'm struggling here. Sorry. See if you can finish that out. What does x equal? Grab your calculator there. So 60 equals 5x. Divide by 5. X equals 12. Then I'm going to plug those in for each one. So PR was x plus 20. And I'm going to do 12 plus 20 to get 32. RQ was 8x over 3. So if I do 8 times 12 over 3, that is also 32, because I really just have 8 times 4. If I think about 12 divided by 3 is 4. And you can also use a calculator. So if you're like, how did you do that math? There's always a calculator. All right, and then PQ equals 6x minus 12, which is 6 times 12 minus 12, which is 72 minus 12, which is 60. So our picture here is definitely not drawn to scale, because we should have the bottom twice as long as our 2 equal sides here, because our sides are 32 and our bottom is 60, but we did get equal side lengths, so we did something right. All right, let's look at this one that's just a little bit different, and we'll be done with isosceles triangles. All right, if a line or a segment bisects the vertex of an angle of an isosceles triangle, then it's also the perpendicular bisect of the opposite side. So if we have this bisector here, this becomes, this length has to be equal to that length, and perpendicular means that it is 90 degrees. Also, this angle must be equal to that angle because it is a bisector, meaning that it cuts it in half evenly. So not you trying to get the bigger slice of pizza, but actually giving you and your friend equal sizes there, okay? So if we have PRS and then we have SQ that bisects this, okay? The RSP, okay, so that's what that did. SP is congruent to SR. RQ is 4. And P is 31 degrees. We want to find RSQ and we're going to find PR. Well, PR is pretty easy. If we know this is 4, this must also be 4 because to bisect that means to cut it in half. And 4 plus 4 is 8. So the length of PR is 8. Halfway there. Okay. RSQ takes a little bit more thought. So we know that it cut it in half, so those two angles are the same. We know that this is 90 degrees. And we know that a triangle, so if I'm thinking about just that small triangle there, is 180 degrees. So to find that third angle, I would do 180 minus 90 minus 31, because 31 was that given angle there, over there on the side. And then whatever that math is our answer. Okay, so giving you a second there. Hopefully you got 59. So this one is 59. That also means this one is 59 degrees. Also means this one is 31 degrees. So now we have found all the angles and part of the sides. Okay, so to answer our question, the measure of RSQ, remember RSQ is this one right here, is 59 degrees. Again, check class notebook for all the other examples on isosceles triangle, and then meet me back for equilateral triangles, which will be shorter than this one.